Hello again, everybody. Today I'm going to show you how you can make an automatic door. This might not be the best way to do it, but this is the way that I ended up figuring out how to do it. So it was something pretty simple. If you've watched any of the other videos that I've made, really there's nothing crazy here. What I've got is just a door and a door frame. So what I'm going to do is select this door frame, the door, and you can see that this is just a dynamic door. And I've got its position set up. Nothing special in here. You can change a couple things about it though if you'd like. Maybe you want a red door or something cool, like a green door. That's fun. So, you can change that kind of stuff around. But I've got a boundary set up in this door frame though. So if we take a look at this, this is, by the way, this is of course a dynamic object. And there is a boundary set on it with a boundary type of box. You can choose whatever you like, cylinder or box. I think a box works good for these scenarios, or works better at least. So just adjust this width and length and etc., all these dimensions of your boundary. And I bet you can guess what we're going to do. We're just going to see if there are any players inside of there. So what I'll do is just select my script brain that I have here for my door. Okay, and I'm going to hold Q and go to node graph. And what I've got here is maybe not the best way to do this. It is, there is quite a lot, I will say, on the screen for just kind of moving a door up and down. I will admit that. And like I said, maybe it's not the best way. I will say that also I don't watch any other YouTubers. So if there's somebody making, better scripts, follow that script, but you're here, so maybe there isn't anything else, or maybe you want to see something a little bit different. So the first thing that I'm going to do, like I always do here, is I like to show you what my variables are. So I have a number door speed here. This is a declare number variable node that I grabbed out of the variables advanced. You always get your declares here. So you always have to declare that variable before you use it, of course. And what I've done is I declared a number variable, and I also declared a vector3 variable. And what these variables will do is control the behavior of the door. The speed here, which I've set, is the amount of time that it should take in order for the door to open or close. So I also have this vector3 initial position, and what I'm doing there is I'm just zeroing it out. I'm just giving it initially just an empty vector3 essentially, but I don't think that that's really necessary. You could probably honestly just remove this. It doesn't need an initial value since we are just setting it right away, but it's just kind of habit for me to initialize things at this point. So anyways, that vector3 initial position stores the initial position of the door. So when the game starts, this on-game start event, which I of course got from events, and then on-game start is the first event. So right when the game starts, this is before the gameplay starts. This is before you jump into the game and you can shoot, jump around. This is right when it actually activates. And then we have this set vector3 variable. Again, that's going to be in your variables advanced, and then set vector3 variable. And the identifier that I've given it here is vector3D initial position, of course, because we're setting the initial position. So what I have here is an object reference to my door. So not my door frame, but my door. We're going to be getting the initial position of this door object. So with that, we've got the initial position because we're going to need it later. Because we're going to move this door and we're going to need to know, where do I move it back to? So if we look over here where we've got this kind of branch right here, it branches off to all of these. This is a reference to the door frame. So something really important here. You cannot put, of course, the area monitor on the door. If you put the area monitor, which is this boundary box, if you're going to define that area monitor using a boundary on the door, then you're going to have the door move up, and then you're no longer going to be in the boundary box, and then the door is going to come back down, and then it's going to go back up, and then it's going to go back down. So you need to put that area monitor on, or excuse me, the boundary at least, and then define an area monitor using the boundaries from that door frame, because the door frame is not moving. So that is why we use the door frame for the area monitor. Now, I've got a couple events here. So the first one we'll start with is on object entered area, and I have done videos on area monitors already, so if I breeze through something, make sure to go back and watch maybe some of those. But essentially this area monitor node, which you can find in variables basic and then area monitor at the top, you give it an object that you want to monitor on the left hand side, and then that area monitor is output to this event. Now this event is saying that when an object enters the area monitor that you give it, so in this case the door frame, the next thing that we're going to do is we're going to branch, and we're going to use the condition get is player. And what that means is this object that you gave me, is this a player? This will emit a Boolean value, so either true or a false. And then the next step that we'll do is just trigger this custom event, which I've created. The identifier I have put between these just to make sure that I don't make any typing mistakes. And to share it, I suppose it was just a little bit less work. So the identifier here is event check door for players. And what I'm doing here, if you notice, these look identical, right? That's because they are. So pretty much the only difference here is the initial event that's invoked here. So we have on object exited area and on object entered area. So whenever anything goes in and out of this box, we're going to be doing this check here. So we're going to trigger this custom event for event check door for players. And basically what that allows for me to do is not duplicate this whole section between these two nodes, and also get rid of a little bit of ambiguity as to like what we're actually really doing. So what we're really doing here is we're saying, again, this is the area monitor, so we're going to go down here to this custom event that we're talking about, this event check door for players. So we're going to get the objects that are in this area monitor. That's going to get you everything. That's not going to get you just players. That's going to get you pop cans. It's going to get you anything that flies through there. So be careful. Make sure that you filter this in the way that I'm filtering this list, which means I'm just going to get the pieces out that I want. What I'm going to do is use this get shared objects node, and what that does is it filters two lists based on the objects that they share between those lists. In this case, we have a list that's coming from this get objects and area monitor, and then I'm just getting the list of all the players in the game. I'm saying get me the shared number of objects in there, get me a list size of that. So get me the number of players that are in this area monitor, essentially at this point is what we're saying, because, right, we're going to filter out. So if a soda can is flying through here, then we're going to filter that out because it's not shared in the players list, if that makes sense. So next, what we can do is just say, get me a list size of that shared object list. And then what we're going to say is if A is less than B, so... excuse me. There was a time when I did change this, as a matter of fact, to where I did A is equal to B. So when it is 0, that would fire the true condition, though. So that is false. And what you'd really want here is an either or. But not to confuse anybody while I'm in the middle of describing this. This is the way I have it set up, and it works great for me. But the object list size here that I'm giving to the operand B, I'm comparing that to 0, and I'm saying if 0 is less than the number of players in that list, then that'll be true, else false. And what I do here on the true condition is I'm just translating an object. So the object I'm translating is the door. So if we go back here real quick, this door is what I'm referring to. This is the UNSC Spartan door. And I'm just going to modify its position. Now, this could be improved. And basically right here what's happening is I'm getting the initial position of that door. So this is the initial position of our door that we retrieved up here and set in our vector 3D initial position. Okay, so we're going to get that position, and then we're going to split it out into its individual components, this vector. And then I'm going to take these Z components. So if we go back into the game real quick right here, if you're not familiar, your Z is going to be labeled blue, Y yellow, or green, excuse me, and X is red. So we're wanting to move the door up. If you want to move the door somewhere else, then you need to make sure to change the code that I have here, or at least kind of what I'm doing, so that it slides in the direction that you want it to. Okay, so if I go back here, I'm going to do Control Z just to make sure I didn't move that in any weird ways. If I go back here, and we're looking here at this add, okay, so I'm adding 10.5 to the Z position, which is the upward direction. If you want the door to move down, then this would be negative. In this case, it's positive, so we're moving in the positive Z direction. And I'm going to create a new vector 3 here. And so the reason why I said I don't like this is because every single time that this has to be, or that this runs, this is recomputed. And so what I mean by that is all that math is done, right? So the machine or the computer is having to do that work. Granted, like, it's easy to say it's negligible, right? But doing that a lot all over the place, pretty soon you might have a little bit of a mess on your hands, especially if you're building something really, really big. So try to think about how you can do that. I know that I can do that here, but I wanted to make a quick video on it. So if you did want to extract this, what you'd want to do here is you just want to do this right at the beginning. So right up here, you'd want to set another, you'd want to declare another vector 3, okay, that could be your animated position, and then do that math here, that initial position here that we're getting, just do that add right here, split that out into its vector components, create a new vector 3, and you could do that here. But like I said, I just did it kind of quick and dirty, and that's what we've got right here. So if that makes sense, we're just taking the position and moving it up by 10.5 units, and then we're saying translate that object to that point. What object are we moving? We're moving the UNSC Spartan door, of course, not the door frame. We are going to get a number variable here. Remember, we declared a number door speed, and the reason I did that is so if somebody just wanted to go into this script and then quickly adjust a couple things, they can do that without having to go read this whole branch of code. Now they know they can just kind of adjust this or configure it, would be a good way to put it, without very much effort. So that's the duration in seconds that we're passing into that translate object to point. And so one last important thing that I want to show you here is this movement curve, okay? I may have mentioned this in the past. I know I've mentioned it in comments to other viewers. This curve here is going to be important for whenever you want to do some kind of animating, right? So that's what we're doing here. We're programmatically animating something. So I'm using an ease in out sine curve. So essentially what that's doing is it's multiplying it's stretching out the time, essentially. It's a little bit tough for me to explain because I have like an internal understanding of it and I haven't really expressed it very much, to be honest. But what you want to do is just kind of mess around with it and kind of get a feel for it. It's not the easiest thing to understand if it's the first time that you've ever approached using curves and how you're multiplying values and modifying things like acceleration based on curves. But essentially what it's going to do here is it's going to smooth it out. So that's a good way to put it, is it's going to smooth it for us. So that's our door. And whenever we enter this area monitor, it's going to open for us. And it's working great. Now, one thing that we could improve about this is, well, one thing that I kind of at least notice is that you should be able to essentially sprint through a door without having to stop. You don't want to stop the flow of gameplay. You see how abrupt that is, and it's kind of like, oh, the players are just trying to get through the door. You know, it's kind of goofy. So I was considering going in here and maybe playing with some of these curves a little bit more. So I haven't tried this yet, but if this looks crazy or goofy, oh, well, there we go. So it looks like the game crashed, so I'm actually going to just stop it there since I had a really good one take, kind of one cut on that video. So sorry about that, everybody. Whoops. I will see you all in the next one. Thanks so much.